Hello, everyone, and welcome to the Amazon Web Services Nordics webinar series. This time, this session is going to be about smart cities and transportation. Today, I have with me Maria Rautavirta, Director of Data Business Unit from Ministry of Transport and Communications in Finland, and Timo Sarenketo, the CIO of Road Scanners Group. And also with me is Wayne Sutter, the Business Development Manager of IoT at AWS. With no further ado, I would like to start. Just a few housekeeping rules. Please post your questions if you have any. We will get back to you. Just so you know, our speakers are having their email addresses also available. You can directly contact them. Otherwise, just feel free to send us a mail and we will forward your emails and your questions. So with that said, I will hand over to Maria and we can get started. Thank you, Maria.
Okay, thank you and welcome everybody to this webinar also on my behalf. I'm Maria Rautavirta, Manager at the Data Business Unit, responsible on the smart city, transport automation, as well as horizontal data issues, and I very much appreciate the topic of today's webinar. It kind of brings together all the development work we have been doing here at the Ministry for multiple years already, but it's evidently coming to concrecy at the moment. So I'm discussing or telling a little bit of how we have been building the data-driven transport sector in our ministry and in our national strategies, but that's as well I'm telling a little bit how the EU is giving the background and how we have to seek for interoperability that is beyond devices, vehicles, sectors, and also cross-border. And the transport is one of those trends where digitalization maybe is not so far yet, so there's a lot to be learned, and especially when the vehicles are moving obstacles, the traditional M2M or development work relating to IoT hasn't maybe yet gone so deep in the knowledge base as well. So we are seeing a lot of potential addressing the challenges for climate, for city development, as well as for efficiency gains and then budgetary issues that we all face. So data is definitely boosting the transport sector. It's done so, but will be even further boosting our development for the next years. EU is kind of giving us the framework in where we operate in the transport sector. And we are very happy to welcome the EU data strategy, in which the data has been recognized to be the minimum denominator that brings together the technologies, connectivity, innovation, and growth. So it's a means for AI utilization, building smarter, more sustainable societies, as well as giving citizens more opportunities to participate and be part of the society. And within the EU framework, we see it very important that the investments we are now doing in digitalization will be kind of benefiting a kind of infrastructure that is agile, easy to expand and scale, as well as takes into consideration the possibility to combine data from different sectors and from different sources. So it's not a small thing on the table at the EU right now when we are talking about the mechanisms and the framework on which the EU data policies will be built on. So You may have heard about the EU Data Spaces Initiative and the governance model that has been planned to kind of incorporate the sector specific development into a more coherent and interoperable European architecture or infrastructure. It's not only a technical project, it involves a lot of legislation, a lot of different things we have to agree on paper as well, and it also incorporates a lot of structural changes to our common ways of making things, as well as to the processes in different sectors. So the Commission data space is part of delivering the EU data strategy, and it's maybe the most concrete initiative that we can discuss about. What we in Finland have wanted to highlight is that the data as it is today, it's mixed data. So the privacy-related data and the anonymous or maybe industry-driven IoT data, they come closer together, and it's very hard to distinguish those from each other, and therefore the solution has to provide a platform for exchange of all kinds of data. So we need to create a system where the privacy-related data, the open data that's already widely available, as well as the corporate and then private data are being exchanged and shared. So the development process involves a lot of stakeholders from all levels of national EU institutions as well as city level. So being able to kind of provide this kind of platform for the discussions is also a necessity for the Europe to proceed. So there's a lot of work already done, and in transport sector specific use cases, we have recognized that transport automation, intelligent transport systems, as well as transport services and logistics are part of the kind of the triangle with the data economy. So they are within the same development basket, as to say. But what we have to ensure is that we will keep the human centricity as a core development leading principle, as well as empowerment of the citizens. This is vital for two reasons. First is that the GDPR is very strict, so we need to create mechanisms that make it possible for the citizens to give consent for the use of their data, so that we can have the most benefit out of it. But secondly, it's also important that we don't look at the technologies or the organizations as we maybe previously have done, but we'll develop this new data sharing ecosystem around the people. So they are also in technical means, they can be those delivering and sharing the data if we take it to the root. So what we also have to keep in mind is that we are not even in EU alone, so we have to seek for global decentralized data sharing infrastructure and trust mechanisms that are widely available and used. And this work we wish to seek standardization that is approaching a vast amount of stakeholders. There are multiple initiatives already, but now we have to kind of test the parts of those and create something that is combining all these elements. In transport, there are 4 modes. Each of those have a different kind of standardization culture, different kinds of decision-making processes, and by finding the kind of the commons, we can develop the by the usability of the solutions we are creating. So we are not building a system of systems, we are rather building network of networks, combining all the knowledge and the work already done. So we are not starting from scratches. But in the background, we also did see that there's a role for enabling, guiding, and goal-based legislation. So the current structure of legislation is too strict on the details. It has to be more goal-oriented and allow more room for innovation and new technologies and solutions. So in Finland, we have during the last 5 years done a remarkable work in putting together all the registries in our sector to fully kind of streamline how the data is being stored and how it can be reused from the official registries. But this legislation work, of course, has to go deeper also in other sectors so that we can combine the sectoral work to the same processes we have. So if there is a 1 week part in the chain, then it makes our efforts useless. In addition to this kind of the 3 elements we wish to see in the future data sharing environment is that the data sharing that we are developing has to also kind of take into consideration that the model of the physical transport infrastructure enables the data to be updated in real time. So we have done a lot of work with the static data, but it's become evident that we are more connected than ever and we need the real-time data more and more. So in some time we thought that having a lot of data is better for the AI as well, but now we see that having accurate real-time data, even for a limited amount, maybe brings more benefits when we are more reliant on that the database is solid and we can trust the database. So bringing the static and dynamic transport data together within these data sharing platforms is essential as well. During our presidency for the EU, we drafted for the EU the principles for data policy, and one of those is that we have to establish sharing mechanisms by default so that the data we have is available to be exchanged. There are, of course, a lot of different disputes on business secrets and corporate issues as well. But if the data isn't ready to be reused, even the decisions or agreements made cannot change the thing that it's been stored in a way or it is made impossible to be shared. So we have to prepare ourselves for the sharing of data, and we see that the APIs and the data sharing structures that enable even maybe unseen purposes for data sharing are the best ways to prepare ourselves for the future. We also see that there are a lot of discussions over whether we can or cannot share data. Maybe we should go deeper and discuss what kind of data we can actually share. So building the data sharing onion from those obvious data that we can easily share, and then maybe being more restricted on the data that we see more concerns over. The picture we then drafted last year was visualizing the case in the Finnish transport sector, where we have a corridor as a service logistics data sharing platform together with other platforms already sharing data, and the vision was that in near future we would have these all combined together so that we can access data from various sources, but we can use them in a one place. It can be also limited in time. So building the intermediate platforms that will bring together as ecosystems is something that we wish to establish. And we are happy to see that also other sectors are going towards this direction, because we also have a lot of interest in spatial data, in data regarding the cities, especially the housing, the streets, and in that also the responsibilities over the data are not so detailed as it is in the national road network, which is usually more centralized to be managed in one place. So we have a lot of stakeholders in the city level, and we see it necessary that we have this kind of flexible system in sharing that data. As one use case, we have a mobility as a service where we have used kind of the legislative stick in order to facilitate the data sharing. So in 2018, we drafted a legislation which required that all transport service providers had to open their essential data for the citizens to prepare their transport needs and to compare different options, whether it was trains, maybe even planes and boats, together with buses and so forth. And in addition to this essential time schedule data and price data, we also required them to open API to give direct access for third parties to their ticketing and paying systems, so that the individuals can purchase the ticket for the whole trip from one location. This kind of approach by obliging the stakeholders to open their markets for third parties, we have seen to benefit the user as well as the government, which is supporting the transport sector as a whole, in public transport especially. So kind of steering the development in our national level, also for city operators, has boosted the development of this mass layer. And today we can see that we have multiple different options for choosing taxi from one app, or choosing our means to make ourselves to work from one app only. And the next phase in mobility as a service is to seek for EU-wide solution, as well as build a roaming solution for the neighboring countries in the first step, and then of course more widely after that. And the kind of the biggest obstacles maybe have not been technical, but more to agree on the soft infrastructure, the agreements, the codes of conduct, which we have also facilitated to support this work. And now that we have a few years of experience, we also see that the model to legislate on not maybe kind of traditional legislation on APIs and such. This is also a functional tool for building the markets and the business cases. So it brings everybody on the same level playing field towards each other. And I think this kind of approach is also beneficial when we have a kind of a goal also for the EU to build a more level playing field for all digital services. So in some cases, the freedom for contracting is maybe freedom for somebody, but not for the smallest players, and this is what legislation can do to help. So my last slide is a little bit about mobility beyond the current situation, where we have faced actually that maybe in all other modes of transport than the traditional cars, the usage of mobility services have gone down. Influencing logistics maybe has not been so big, but there's even more need for trusted data on the behavior of citizens. We already see that the vast amount of remote working has had an effect. The traditional rush hours are not there where they used to be, so the history data and the data we have stored so far maybe is not the best data to predict the future. And for logistics, the traceability and tracking data is now even more important than previously. So we are also building kind of the data infrastructure that has to go over the hurdles and obstacles that we have faced now. And I think this digital leap that we have been forced to take during the pandemic is a good reminder of us that whatever we do in the means of data, it has to serve the people, it has to serve the societies and the functioning of businesses and the society as a whole. So building decentralized data sharing ecosystem is also the best way to guarantee that we are not putting all the eggs in the same basket. Thank you. This is pretty much all I wanted to share with you. I'm happy to give further information on all our approaches. And I would like to now give the floor to Timo Saarenketo as the next speaker.
Hello everyone, my name is Timo Saarenketo. I'm a CEO of Road Scanners Group and also acting as adjunct professor in Tampere University in traffic infrastructure diagnostics. And I'm going to talk in this seminar about Road Scanners web service for traffic infrastructure asset management. Road Scanners in general is 22-year-old company, and it is focused on developing software and hardware for traffic infrastructure asset management, but also we have a consulting branch and we are doing quite much work by ourselves. And where we are focused very much is digitalization and new digital tool, and our expertise is using technology that combines the surface information of the roads, or in this case airports, with the subsurface information. And all these technologies requires modern equipments, and especially the data sizes are extremely big ones. Road Scanners is also international company. We have had operation in all 5 continents, including Antarctica, and roughly at the moment 62 countries, and more than 60% in general is from our turnovers are exports. In general, why we've been ended up of this web services has been traditionally over almost all my career on the road has been the big data. And the left, for instance, the photo on the left shows when I was working for Finnish Road Administration in 80s. the first vehicle to survey road structures in '87. And at that time, the data size was already so big that the computer that we had to PC that we had to pay to cover and to be able to analyze this data cost more than this vehicle and all the instruments together. So big data in general has been always, because once we have had more effective PCs and storage systems, so then also the quality of the instrumentation has been increased, and data sizes and accuracy has increased. So like in Wikipedia, it defines that the challenges in big data is capturing data storage, where you store this data, how you analyze the data, where you search the data, how you share that, how do you transfer the data, how do you visualize, how do you query the data, update, information privacy, and data source. They are, all of them are actually our everyday problems in data management. Our web service history starts from 2011, when we started to have first products for asphalt paving quality assurance systems. Before that, asphalt paving systems were mainly done that you were doing asphalt pavement, and then later on you tried to measure the quality. And of course, at that time, it's many times too late. The damage is already there. So we found out together with our research partner in US that we have to move forward or towards quality assurance real-time systems, and that requires fast delivery of the data and results. And we made the first system for contractors, because they were not contractors and their management was not always on the site. And we started to do this on GIS portals. Managed pretty well with our own server. Then in 2015, it was like the first bigger step on web service on street doctor survey data, where we did some bigger cities, their street structural condition and performance condition, and analyzed that and stored that to the our own roaddatacenter.com, and at that time it was in our own server. But very soon we found out that we had issues with the scalability, backups, management, service level, etc. And we found out that we are definitely not experts on this issue. And in 2016, then when we started with Finnish Transport Agency, this PEHKO 2015-2025 project, we decided that we have to select some web service provider and to handle all the huge data that we are working on, these 3 test areas that were selected on this area. And on this evaluation, we selected Amazon to be our service providers. And many of our issues and problems disappeared. Anyway, the software still had to be done by ourselves. It was only service providers, and especially in 2017, when point cloud data started to became more and more popular in the evaluation of our results. There were problems with the how fast the system was, and we got some feedback that this should be much faster. we focused on that, and 2018 we got an update on the road data center, and with the user in the phase, especially processing time, and immediately our happy users amount increased substantially, and all the new and no negative feedback from the new users. Then in 2019, last year, because this started to be so popular, because we are selling our technology to others, so they wanted to use the same platform for their clients. So we started to sell also the services to other clients where they can show their data on the same platform. And this year, so far, or data delivery of most of our road scanners projects are already done through Road Data Center, and we are just actually most likely next year signing a big contract with the one of the biggest countries in Europe for their asset management project, and all the data deliveries will be done through this system. So Road Data Center at the moment have like three type of application where we are working. It's what we call where we did this system initially is this Road Doctor Paver for asphalt quality control. Then the next one is a Road Doctor Web, which is all kind of service related to asset management and quality control, and finally RDMC, which comes from the word Road Doctor Maintenance Controller type, but that is mainly focused on autonomous driving and this based on the research work what we have been doing to develop products for autonomous driving. Here's one example of our user interface and how we are providing clients. This is the project what we made a few years ago to Macedonia, and this is just this interface showed real time to the clients where we have been doing data collection, and actually also could even see where the car is driving at the moment, and if we are meeting the time schedule, and we have been using in-house in own management, but also for the customer very useful on this kind of service. And on the left hand you can see the list of the countries that so far we've been using on this technology. Next slide comes from this PEHKO project with the Finnish Transport Infrastructure Agency that we've been working, and all this information, all kind of results that we are doing on the diagnostics and good quality asset management are presented in this platform. Here is just one example of the Uusimaa area, very close to the Helsinki annual RAT increase, which is the critical parameters for calculating the annual paving cost. Because if annual RAT increase, for instance, is more than 5 millimeter per year, the payment lasts only 4 years, because you cannot allow more than 18 or 20 millimeter RAT thick depths. And with that you can calculate also the map on the areas where you have very expensive roads, like in this case these black roads, their annual cost is roughly 8 to 10 times more than the blue roads over there. And even inside to the blue roads, you see a lot of black dots that we are now focusing and finding out what is the reason that causing them to be so expensive and fixing them. And what we have found out on our services that only 10 to 20% of the road section, but they are taking more than 50% of the maintenance cost annual in our test areas. And theoretically, if we are fixing these areas, we can cut down up to 50% of the annual paving cost. So savings you are talking about more even in theory and in practice, even in Finland, more than 50 million euro savings per year. So we are talking about big amount of money. Here's just one issue then showing in practice. This is one of the motorway of our clients on USA, and just showing that in addition to show something on the surface, but you can show also structural information, and like in this case showing that on this test lanes, the left lane yellow has much thicker pavement than on the right lane, and that is very useful information, for instance, when they are designing milling of asphalt and other rehabilitation measures. This example then comes from this real-time road condition monitoring. And that we've been working on, especially on autonomous driving and road condition management. Our vision is that like in the future, that most part of the information about road conditions will be collected, you and me, everybody who is driving these cars, because these modern cars are loaded with different type of sensors that are measuring and monitoring the how rough is the road or what type of bumps and everything else. And for this service and in the future, a web service plays a very crucial role. And at the moment, for instance, in our test cars, we have managed that once they are driving on the vehicles, so they are sending through 4G network this info. First of all, they are processing the smoothness from the sensors, then they are sending the information and to the web, and the results can be seen in 2-second delay at the moment based on our experience. So basically, if this Honda here hits a bump, basically after 2 seconds it's in the web service, and basically after that it can warn the next cars that are approaching these areas, and warn that okay, there's a serious bump or whatever. And for instance, here also, because we are in the very north and we have problems with the frost, so you can see at different time how the frost bumps are developing, like and the worst roads can be measured in early May, when in the January, February, it's relatively smooth. So how we see like a next generation road asset management with ITS is that we have to have like a big road data centers that these cars are sending the condition information. Then we have to have some structural data information collected with the special vehicles, and this road data center has to provide information also for the maintenance crews. And as I said, that if this car hits a potholes, bad potholes, so this information has to be delivered very fast also to the maintenance crew to be fixed. Right now, with this system is mainly by telephone calls and everything else, and this process can be pretty slow, that it can take even few days before this can be fixed, but in the future world, this can be, especially on the critical circumstances, this can be really, really fast. And of course, the big benefit is that everybody are warned about these problems immediately. Finally, how we see the web service-based data management is that here's a list of what we say. So first of all is that we've been seeing so major improvements in data processing, storage and deliveries. And then the other issue is this, that without this web service, there are many new innovations that we've been doing and are developing at the time, that are based on the real-time service products. So IoT is definitely coming to be a big issue on the roads and traffic, and of course safety, especially on the safety side. Then on our own consulting business, the big benefit is the productivity and project margins. So basically, in the beginning, because of this huge data sizes, the project margins were very thin, but now the productivity have been improved, and we can also offer this service with much lower prices. Data quality has been improved because this visualization is immediately highlighting mistakes. So if you see some strange results on the map or this kind of point clouds, we can go and see and find out that we probably have collected bad quality data, and we have to correct that. So that is very, very big benefit on this visualization also. Like this is one example on the photos on the right hand side, that there is a green area. This is from Norway. Green area presents high rutting, and then this blue and red area present where you have a high amount of moisture. And in this case, you see this red area which is under the road, matching perfectly with this green spot, and that tells you that you have a moisture problems. And once you see private access road junction over there and no culvert, so you know that is the reason for these problems on the road. And it's very cheap to be fixed, only a few €100 to replace a culvert on this case. So it helps very complex data to understand. The problem with our asset management is that many years and years we have been delivering data like Excel tables, boring Excel tables. It's really hard to see anything special, but this focuses even 1 meter accuracy, your problems in the correct places. And finally, of course, that we can bring this data also in the field. So if you have a tablet or telephone, you can see the same screen in over there and view and look under the road like a Superman, and maintenance crew exactly can go to the correct place and do the correct measures. And if you sum up all of these, is that this leads to, of course, major savings to the society. So with these words, I thank you, and now I hand over the presentation to Wayne.
Hi, my name is Wayne Suter. I'm responsible for technical business development across EMEA and also focusing on our smart city strategy. Since opening our virtual doors in 1995, the retail business Amazon.com has had the single-minded goal to be Earth's most customer-centric company. And that early day goal is still 15 years later on our core focus within AWS, with our key leadership principle to be customer obsessed. Everything we do revolves around that principle in a very real way. When looking at cities as our customer, we recognize that the city too has a customer and they in turn are obsessed with, and that is the citizen. Every action a city takes is designed to benefit and enrich a citizen's life in some way, whether that is to bring in new business, improve traffic flow, reduce crime, or become a tourist destination. It's all driven with the end customer, the citizen, in mind. But in order to make good business decisions, cities need to make it on data, which brings me to our definition of smart places. In order for cities, regions, or councils, or any organization to make good decisions, they need to make data-driven decisions. But in order to make data-driven decisions, you need to have control and ownership of your data. And that's what we're here today to talk about. So these organizations have a lot of complex challenges, and more so than many other types of organizations. There's lots of standalone data sets, some that may mean on individual PCs or servers. Some of the data siloed. The transport team will probably seldom talk to the health and social care teams. There's data governance issues with a lot of this data spread around the organization. Onboarding new data use cases can be difficult. Each new use case is completely different, using new hardware, new connectivity, new storage mechanisms. Vendor data lock-in. This is one of the biggest issues that we come across. Organizations, where working with suppliers over time, they find that they are locked into supplier solutions through the fact that they don't have access to their data. The next one that is a big issue is attracting and retaining the kind of right skills. So a lot of organizations in the city space, especially kind of rural organizations, they struggle to attract in the level of skills that they need to be able to manage their own data. And even if they do manage to attract those people that can help in, they struggle to retain them because that they're in demand from the commercial sector. And so a city may struggle to be able to pay the salaries that the commercial sector can pay to retain those kind of individuals. Cities are very keen to be able to control their and open up their data to the developer ecosystem, or to kind of startups or to other cities that they may want to share their data with. And then lastly, being able to do cross-vertical data analytics and AI/ML across their different data sets can be tricky. And the common thread to all of these challenges is data. And so I'm here today to talk to you about how AWS can maybe help you overcome some of these challenges and be able to control and own your data. And so we've developed this program bringing together all of AWS's different services. And what we've got initially, we work with cities to put in place some relatively simple foundations, but they are absolutely key. The foundations are the most important part, to be able to have the infrastructure in place to allow them long term to control and own their data. And once those foundations in place, then we can move on to a growth phase, looking at how we can commercialize or democratize their data and tap into some of our higher level services. And then finally, we look at how AWS can play a role in the future communities of those cities. And I'll go through all of this in more detail in a moment. So the status quo that we find the situation with many cities is that they, as I mentioned earlier, they've got perhaps standalone data sets within the council or city, maybe some even on master data, even on individual laptops. And many of the solutions they bought in over the years tend to be vertical solutions. So they've bought in the hardware, the connectivity, the data flows into the supplier's data store, and the supplier gives some kind of dashboard or access to visualize that data. But the problem is that maybe the city has API access into that data, but even so, that's a curated view of that data, or at worst, they've got no access to that data at all. And therefore, in order to get to do cross-data analytics, to get value from maybe pothole data that they've been collecting from the community, to relate that to the traffic flow using their CCTV system, and maybe using some IoT devices, say their smart car parking devices built into the roads to detect the weight of the vehicles, to be able to do that cross-data analytics across those data flows. They can't do that because they don't have access to that data. And so to do machine learning or third-party analytics is next to impossible. So we are looking to work with cities to help them get control and ownership of their data. And this is a long journey. This isn't going to happen overnight. But the idea is that over time, to be able to get some more control over your data, get it flowing into a cloud that the city has the keys to, and they can decide what they want to do with the data. They don't need to do this alone. This can be done with partners. Partners can help set that up. But the bottom line is that it needs to be the city's data store, so that if they want to move it or change suppliers or change the partners that are helping them, they can do that. They no longer have that data lock-in. For some data flows, they might have trusted suppliers, like we looked at earlier with the road scanners. Perhaps with that data stays with road scanners, but there's API access in to be able to get access to the data that the city needs. And what this means is that the city can then, give access to suppliers or their community, and they can open up their data via API to be able to share it out. And it also means they can do that AI ML analytics that they've always wanted to do. And we do this through these three phases. As I mentioned earlier, first there's this foundation phase, being able to put in place some core infrastructure and being able to migrate a couple of data sets, to quickly get it on and get some value, get some analytics and visualization going. And we can help cities do this very, very quickly. And the point of this is to be able to understand and understand the complete kind of flywheel of that process, to be able to get to the point where you're actually getting value from your data. And if that works for you, then we'll work with you to get to the next level, which is to explore how you can then commercialize or democratize your data, or tap into our OGS or open government solutions to be able to share out some of your source code or data with other cities. We've got data exchange, which enables cities to commercialize their data, and it automates the contract process. And maybe some of that data you want to give access to free of charge to some types of organizations, but then other organizations you want to charge for that data. We've got robotic process automation to try and automate the actions that will come out of the insights that you get from your data. We've got predictive modeling, behavioral analysis. We can look at how how we train up your staff with, how do we get your staff up to speed to over time become more self-sufficient to be able to manage that data and those processes that you've got going, or maybe just being able to make good decisions when you're working with your partners as to how to manage the data. Lastly, we look to the future, because AWS is a member of your community in many ways. We've got many of our employees probably living or working in your community. How does AWS can bring to bear their education programs and community programs to educate the children of today to be the cloud architects of tomorrow that will work on your data within your city? Or in the business community, how do we use our innovation or acceleration programs to attract in the startups and the SMEs to maybe use the data that we've shared over here to build applications for your citizens to use in their city. And so where we want to get to is to help a city get a single view. And what we mean by that is to have a single view of whatever area they want to focus on. So for instance, we've got a customer, Hackney in London, where they wanted a single view of their citizen. And in COVID, they needed to rapidly get insights from their data, able to kind of focus their limited resources on which citizens were vulnerable citizens. And so using AWS, they were able to stand up very, very rapidly data sets to give them that single view of the citizen. Or it might be, for instance, the single view of your transportation solution. How do you have a single pane of glass across all of your buses and trains and all of your road infrastructure? And cities have a huge number of data sources that they get access to. And today we're probably largely talking about just one of these threads over here. But in fact, you don't need to have access to all of that data all of the time. You can get huge value, significant value, just from a small number of data sets. So here, Transport for London, just tapping into 3 data sets, were able to extract significant value. What this created was a developer ecosystem of over 6,000 developers who are now engaged in digital projects using TfL's anonymized open data, spawning over 360 mobile apps to date. For TfL, this enabled them to deliver a better level of service to their citizens with almost no cost implication to themselves, while at the same time adding over £130 million worth of revenue into the London economy. The Driver Vehicle Standards Agency, or DVSA, is responsible for driver and vehicle safety in Great Britain. The DVSA relies on a team of over 266 vehicle examiners to carry out spot checks on almost 100,000 testing centers and garages. Deciding which garages to kind of spot check was a manual, kind of paper-based operation until now. But AWS machine learning partner Kainos built a risk modeling tool to identify abnormal MOT testing behavior patterns, and the model has prompted 3,200 site reviews, of which 74% resulted in an unsatisfactory or needs improvement rating. Transport for New South Wales, or NSW, is the government agency responsible for the Australian extensive public transport network, including rail lines, buses, ferries. Its role is to lead the development of a safe, efficient, and integrated transport system to make New South Wales a better place to work and live. But what NSW wanted to do was to predict customer usage across the network using real-time weather patterns and other data sources. By using Amazon SageMaker, a fully managed service enables every developer and data scientist to build, train, and deploy machine learning easily. The teams managed to train their model in just 35 minutes with no special skill set required. This enabled them to predict customer usage up to 48 hours in advance. So this brings me to the close, and what I wanted to say is that if this was interesting, there are a number of ways that you can engage with us. There are executive briefings that we can do where we get your execs to meet with our top execs and kind of share learnings, share what we've learned over the years on how to kind of maximize the value of data in your business. We've got working backwards workshops, being able to look at your challenges that you're grappling with that we mentioned earlier and figure out how we can bring to bear the power of AWS to solve some of those problems for you. Or you may just want to have a chat and just explore some ideas of how we might be able to support you. And in which case, there's my email address on the screen. Drop me an email, and happy to have a chat.